BTEC Applied Science for AAQ, and this physics video on electricity is about the equations that you need to know. So we're going to look at these equations and we're going to do a bit of practice using them. So these are the equations. You don't need to learn them. They are on the formula sheet. However, I think the tricky thing is figuring out which equation you're supposed to use, getting the information from the question. So you read the question and let's say you're given the current and you're given the voltage and you figure out, which equation do I need to work out the power? It's the first one. Okay. Be able to change the subject of the equation. So power is current times voltage. Current is power divided by voltage. Voltage is power divided by current. So I am changing the subject of the equation. I'm rearranging the equation. Always do that before you start bunging numbers in, by the way. Make sure that you use SI units. So if the information you're given is like kilowatts, like 3 kilowatts, then in the equation you say 3,000. That kind of thing. Give your answer to a sensible number of significant figures. So the final answer should either be 2 or 3 significant figures. I'll talk about that later. And use the correct units. If you're working out the current, then your answer should be amps. If you're working out the power, then it should be watts, etc. So the correct unit for your answer. Okay, so what current will a 3 kilowatt kettle draw from a 230 volts mains supply? So this kettle, you plug it in and we say that it draws a current, like drawing water from a well. So what current will it draw from a 230 volt mains supply? Well, so what equation are we going to use? In fact, you have a go at this by yourself and I'll show you the answer in 3, 2, 1. So there you go. We know the power, which is 3,000 watts, 3 kilowatts. We know the voltage. So I'm going to use P equals VI. So I equals P over V. So 3,000 over 230 is 13 amps. So 13, that's 2 significant figures. Perfectly okay. Here's another one. Again, have a go yourself. Pause the video. I'll show you the answer in 3, 2, 1. Okay, so we're given the current, we're given the voltage. First thing, resistance. So R equals V over I. V equals IR, R equals V over I. 18.2 ohms. I could have just said 18 ohms. That would be 2 significant figures, but I've said 18.2, 3 significant figures, ohms. Yes? For doing that, there would be actually 3 marks. So a mark for putting the information into the equation, a mark for actually working it out correctly, and then possibly a mark for the units as well. So even if you don't successfully do it all, have a go at it, do as much as you can, and you never know, you might pick up a couple of marks. Calculate its power, P equals IV. Yes, and we're given I and we're given V, 1.98 watts. I could have said 2.0 watts. That would be 2 significant figures, but I thought 1.98 watts looks okay to me. Another one, have a go at that one, and I'll show you the answer in 3, 2, 1. Okay, so we're given the voltage, we're given the current, so P equals IV, yes, 5,600 watts. I could write 5.6 kilowatts if I wanted to, but that's okay. How much energy does it transfer in 30 minutes? Now, there are 2 ways you can do this. You can do energy is power times time, because power is energy over time, so energy is power times time. Be careful with minutes, obviously it's got to be in seconds. So 10.1 megajoules, 10.1 million joules. Again, I could just say 10 megajoules, that would be 2 sig figs and that would be adequate. Or I could do energy is VIT, which is one of our equations. And amazingly, you get the same answer. Here's another one for you to have a go at. Lots of practice. You do these, yes? Get your calculator, get these done. And I'll show you the answer in 3, 2, 1. Okay, so we're given the voltage and we're given the power. So I equals P over V to get the current. R equals V over I to get the resistance. And then T equals E over P to get the time, 167 seconds. Okay, just under 3 minutes. Another one, lots and lots of practice. Okay, have a go yourself. The answer in 3, 2, 1. Okay, so I've given you the power in kilowatts. I've given you the current. So the voltage, V is P over I, 688 volts. And the resistance, V over I. V is P over I. And then R is V over I, 21.5 ohms. 22 ohms would be okay. That would be 2 sig figs. Okay, now I want my students, when I teach physics, to actually understand a bit about what does voltage mean, what does current mean, what does resistance mean, what does power mean. Electricity is not an easy topic. I know a lot of students find electricity very, very difficult to get their head around. What I would say is that if you don't get taught a good understanding, you can still actually pick up a lot of marks by learning the equations, bunging the numbers in, work it out. Don't forget the units. Basic math skills with practice, you can pick up lots and lots of marks. It would be a shame if you weren't taught what these quantities mean. It would be a shame if you didn't do any practical work as well. But you could still pick a lot of marks up just by fiddling with numbers. Okay? To do that, practice, practice, practice.